Hey everyone, and welcome to this IMechE webinar. Today we will have a look at how you can leverage the power of the cloud to perform mechanical engineering simulations using SimScale. I'm your host and moderator for today's session, Yusuf Murad, and I'm a product marketing engineer here at SimScale. I'm joined by my great colleague from SimScale, namely John Wild. With nearly 20 years of experience in the industry, John is an expert in simulation and is responsible for product management at SimScale. At the end of the webinar, we will have some time to cover all your questions in the Q&A session. So if you have any questions about the webinar or SimScale in general, please put them in the chat or the Q&A box, and we'll make sure to take them one by one at the end. Let us have a look at today's agenda. Today, we will be demonstrating the benefits of engineering simulation in the cloud by exploring and optimizing CFD, thermal, and mechanical designs using a multiphysics application. And at the end of this, my colleague John will show you a demo on how to actually use SimScale for this multiphysics application. So let me briefly introduce SimScale. We see many engineers and designers new to SimScale who are curious to learn what we are all about. So let me briefly introduce SimScale to those who are not familiar with our platform yet. So we are committed to making engineering simulation more accessible, from thermal, structural, and fluid simulations to other industries who couldn't afford simulation so far. And we strive to introduce digital prototyping into any R&D cycle. And this happens by adopting digital prototyping, which means that we can explore the full design space with the desired accuracy and reduce trial and error that comes with the physical prototyping. So basically, in summary, we are focused on delivering computational resources that scale up on demand. We offer streamlined simulation workflows and offer modern sharing and collaboration features. And we'd like for engineers and designers to be able to simulate early, simulate more, and especially simulate now. Let us quickly have a look at the theoretical aspects of cloud computing and compare them to traditional CAE tools. So on the left side, you can see traditional CAE tools. And what that usually comes with is, and I will talk about this on the next slide as well, is that you basically have to do a 4 or 5 digit upfront investment for your HPC hardware, which adds up to several thousand euros. And you even have to prove the added value before you even start your first simulation run. This is highly coupled to the high fixed costs which comes with that, and also the big know-how barrier, which needs special education and training, or even years of experience in the engineering simulation field to master these tools. On the right side, we see SimScale, where there is no hardware required. So basically, you only need an account on SimScale and a decent internet connection, and you can get started. This makes SimScale very cost efficient, so you have no fixed expenses for hardware, and everything is a use-based pricing. It's also very easy to use. Namely here, what I already mentioned is the seamless collaboration feature, and what I'm very proud of, our world-class support. So here, let me quickly spend a couple of minutes maybe to talk about simulation and how it will be used in the future, especially from a SimScale perspective. What you can see on the very top is a conceptual breakdown for the product lifecycle, going from the conceptual phase over to the manufacturing and production. And most simulation processes or designs are working like that, which you can basically see here. So which admittedly, if you have a look at it, is quite trivialized and a very simplistic way to look at it, but captures the status quo of the most workflows quite accurately. Typically, what you have is on-premise hardware rolled out on an elaborate software or IT stack, which costs you not only a fortune, which I already mentioned, but also requires orchestration between different teams like engineers, IT support, and potentially other vendors to support you in your simulation journey, which is relatively complex. Note this is on purpose, but at this stage of the design cycle, because it's actually like that in real life, so really late in the design process. So when there's a mature CAD geometry, then I'm using simulation. It's basically this if-then scenario. Once you have a mature CAD, you can then adopt this technique. But now there's a lot more to that. Today, there's a lot more movement going from reactive design. So once I have my CAD, how can I react to that once it's ready? To basically iterative design. So simulation, adopting it in the early stages of design and engineering. So basically simulation driving the whole design process. There's also a lot of other things. So going from the conceptual phase, things like generative engineering, up to the operations perspective, where you have things like digital twin, leveraging digital twins, and also modules in terms of predictive maintenance, advanced manufacturing, and so on. How is SimScale leveraging this or approaching this? All the IT complexity that I basically mentioned is taken by SimScale and handled by us. Whether it's data storage or node handling, all the various bits and pieces you basically don't want to deal with. So the end user basically doesn't have to worry about, in this case, you. On top of that, we have integrated a lot of neat technology modules that are tightly integrated into SimScale, such as CAD editing, meshing, and a lot of other capabilities, which you can basically see right here. And these capabilities then range from structural mechanical use cases up to thermal use cases, but also CFD capabilities. And everything is packed into one single SaaS application, namely SimScale, which gives you access to all of these analysis types. Everything is accessible via a graphical user interface, so GUI, but also accessible programmatically via standard API. So our SDK is available on GitHub, where you can use C# or Python to develop your own apps. This is not all by us. There are a lot of third parties involved and also a few that leverage our API. If you are interested in that, we are more than happy to share a few customer success stories with you. So a few examples, what you can see here. I don't want to delve too much into them, but this is basically what you can do, and a few examples of that. What I'm really, really excited about is battery crash test analysis. That doesn't only include crash test analysis, but you can also simulate different battery cooling designs, which we, for example, do now with one of our flagship customers, Rimac Automobili. Very excited. This also ranges to bolt pre-stressing, which you can see on the bottom right side, but also drop tests or eigenmode analyses. And now I'm handing over to my colleague, John, who will walk you through multiphysics analysis of a globe valve. John, the stage is yours.
Cool. Thank you very much, Youssef. Appreciate the introduction of myself as a great colleague, very nice, and of SimScale, very cool. Okay, what I'd like to do is take maybe 10 or 15 minutes and just walk through a demonstration. So we're going to be focusing on a multiphysics analysis of the globe valve that you see on screen. So this valve has fluid running through it. Actually, it has gasoline running through it from left to right. And we want to understand a few different things, and we can use SimScale for all of them. So the first thing we want to do is to run flow through it and get an understanding of how efficient the valve is, maybe in different opening positions. And we want to understand, does the fluid recirculate as it passes through? If it does, then it gives us a really nice opportunity to optimize for efficiency. So any of that recirculation is just a waste of energy, and we can design away that problem. Then we'll look at thermal shock, where we can look, instead of the fluid, this time at the structure, applying a changing internal temperature to essentially shock the valve as the temperature of the fluid changes, to look at what happens within the structure to make sure it's safe. And then thirdly, the same kind of thing, but with a pressure test this time. So we'd have changing temperatures and pressures internally. Normally what happens when the fluid is turned on is some kind of water hammer effect. We want to understand, okay, what happens if there's this big kind of pressure rise, and is the system going to be safe? So there's 3 slides now just to kind of summarize those, then I'll jump into SimScale and show you how we would do that for real. So firstly, the CFD part. Here we are just looking at flow. So we've extracted the fluid volume from the CAD that we have. The flow is moving from left to right. The cut plane is showing velocity, and you can see the blue is the low velocity regions, and the orange and yellow, sometimes moving towards red, are where the flow is going fastest. And what we wanted to do is to reduce the amount of recirculation that we have in the valve. Unfortunately, with this design, you can see that there's definitely recirculation. So there's some at the bottom, even before the flow enters the main body, and then it all recirculates as it passes through and after the poppet. So we can do better there. Then we can take a look at the thermal shock analysis. So this is where we are not looking at the fluid now, but where we are using the original CAD to apply a changing thermal load to the structure to see what happens internally. And we really want to know, do any of the components reach the yield stress, and is it going to be safe? And that will give us a good indication of what the lifetime of the valve would be. And lastly, similar structural analysis, but this time only with pressure. So we would just really load the whole thing up as a pressure test and see what happens. Interestingly, this time the loads are in different places. So if I go back 1 slide, they're actually more within the connections of the pipes and the valve, the high stresses, which are the red zones. When we run a pressure test, they're actually more within the bolts. And on the bottom left, we can see those red areas highlighted. So it helps us to understand this is where the problems are going to occur. Okay, now I'll jump across to SimScale and I'll show you how we would do this for real. If you have any questions, feel free to ask them in the chat and we'll answer them either as we go or maybe at the end of the webinar. Okay, so this is SimScale. It's running purely in the browser. You can see the URL up here, which we can share with colleagues or anyone we want to if we want our project to be seen by others. So it's a very collaborative workspace. This is our post-processor, and this is the thermal shock analysis that we're working within. Here we're showing temperature, so you can see the cold areas at the top are blue, and the warm areas on the inside are red. And we can animate this, so we ran it transiently, obviously, because the temperature changes quite radically over time. We've obviously exaggerated the displacements that you see, but it gives you an idea of what would happen as the material heats up and expands, and then cools down and contracts. And our design question was to ask, are any of the components passing above the yield stress? And we can do that. So we can shade by stress instead. And if we want to, we can identify the regions that have the highest stress, which you can see between the components here and here on the left and right. And we can understand, okay, are these above or below the yield stress? So we can make sure that our valve is going to be safe. Within the same project, SimScale is a really multi-physics environment, so we can solve lots of different types of simulations all from the same place with very, very similar workflows. So we ran a structural thermal shock analysis. What we can also do is extract the fluid volume from the CAD, which is what you can see here. Now we don't need the solid anymore, we just need the fluid. And we can set it up and run the fluid analysis. We would set it up a little bit like this. So on the left-hand side, we assign materials. So here we've assigned gasoline. You can use our material database, or you can totally customize and create your own materials if you need to. There's a couple of boundary conditions that you can see here on the left and right. So we've got one pressure inlet and one pressure outlet. Everything else is pretty much done for you. So there are a lot of controls with numerics and IMechE, but everything is set to default settings, and normally everything works very nicely and should give you a decent accuracy. So once this is run, again, it's run in the cloud, so nothing is done locally at all. Everything is pushed to a remote server, and then we can start to look at some results. So what we're seeing here is a coupling through the middle of the valve showing pressure. The flow is going from left to right, so we've got high pressure on the left and low pressure on the right in blue. What I could do is change this cutting plane from pressure to show velocity. And that gives us an idea of what's happening. So you can see the flow starts to jet through the middle, but it's not giving us an idea of whether we're seeing recirculation or not. What I like to do for that is to show traces. So if I change this back to pressure, I actually have some traces pre-set up. All we simply do is just click at the inlet and say, hey, throw some traces in here, and it will throw some particles through the valve. And we can very easily see that, yes, we have quite a lot of recirculation on the left and over here on the right. And we can animate this too. So it's a nice way of really seeing what's happening. What I would do at this point is answer a couple of questions as well. At least one of them applies exactly to this. So one question is, can SimScale simulate airflow? Yes, it can. So like we looked at materials up here, we're running with gasoline in this case, but there's lots of different types of materials. So we could run with air, carbon dioxide, or you can create your own. So you can run with Newtonian, non-Newtonian fluids, pretty much anything that you can create here. Okay, so that hopefully gives you a little introduction as to what we can do with SimScale, that everything is browser-based, and it's also a multi-physics environment, so we can set up all these different types of simulations. Lots of them you'll see here. I think the other great thing is how it can be used as part of a collaborative tool. And that's what I'd like to show now. So this is a similar analysis project. We're going to use the same valve, but this time we are going to use it as a template. So what's actually happened here is that an expert user who knows simulation very well has set up this project, and they've set it up in a way that a novice user or someone who's new to simulation, wants to learn, can leverage the simulation engineer's knowledge to create their own analyses. And so on the left-hand side here, we're going to run a flow simulation. On the left-hand side here, you'll see these red circles where the novice user needs to do something. So firstly, what he needs to do is upload, or she, firstly, what they need to do is upload their CAD. And that's what we're doing now. So we're bringing it from actually locally, but you can bring it from a native CAD tool or from a cloud-based CAD tool as well. All of it works the same. And then once it's in SimScale, what we can then do is work with it. So if we wanted to, we could run a thermal shock analysis using the structural part. What I'm actually going to do here, because we're going to run a flow simulation, is not use the structure, but use our CAD mode to extract the fluid volume from the solid. So this is our tool here. What I'm going to do is create this fluid volume. So there's lots of different things we can do within CAD mode, like creating a fluid volume. You can delete parts, move parts, fix the CAD if there's lots of interferences and you don't want them for your simulation. So there's lots of different things you can do at this stage. The other good thing about being cloud-based is that we have a live chat available. So on the bottom right, at any point you can open up chat, and you can see right now there's a few different engineers online. They're all colleagues, they're all really simulation experts, and they're always here to help. We have a couple of minutes response time, but then you can get support from somebody who understands engineering, understands your problems, and can give you live support. All of our projects are private by default. Well, if you're a paying customer, or your projects are private. For the trial, they're not, they're all public. But in the bottom right here, you can click to share your project with SimScale support. So initially your project is private. If you click to share it, that engineer can see your project and they can jump in and start to help you in the moment. So there's no need to file share, no need to wait or anything, like is honestly quite common from my experience. You can get support exactly when you need it. We can also do proactive support too. So if, again, we don't see users' projects, but if the user is having lots of repetitive errors, we can just message them, pop up the chat and say, hey, I can see you having lots of meshing errors, for example. Can I help? And we can jump straight into the project if they want assistance and help. And you would see at the top here a small circle where someone has jumped into your project to give you assistance. Okay, so to finish up with this project, once the new user has created their fluid volume, they're simply going to walk through this template to create their analysis. So they first need to choose the geometry. They need to choose the material that's already been predefined for them. I think everyone designing everything knows everything about what they're doing. So the engineer is going to know where the inlet is. They're going to know where the outlet is. All of the other controls have been set up by the simulation expert. So, or anything to do with simulation controls, numerics, all of the mesh settings are all preset. The user can change them if they want, and there's total control over everything if you really want it. But in this case, this user's learning. They don't know, so they're just going to press run to run the simulation. It gives them an idea of how long it's going to run, how much it will cost, and we press start, and it simply goes off and runs in the cloud. If they want to, from here, we can start to make changes. So if we wanted to maybe make a comparison, okay, this time we want to run with 2 bar at the inlet, just to see what would happen. We can change it and set off another run. So you can set off as many as you want. There's really no limitation. And you can actually batch run all of these and push them all to the cloud. Then we can really start to answer the design questions that we have. Okay, I think that mainly covers everything I wanted to show with SimScale to begin with. Hopefully it's a decent, short, but comprehensive enough introduction to what is a cloud-based tool, a collaborative tool, and a multiphysics tool that works from CAD all the way to post-processing in one place. So now I'd invite you to also try the same. you can easily get started with any of the simulations that we've shown. So there's a link here. Yeah, we'll also paste it. You'll have access to it later on when you see the presentation. Then you can jump into any of these projects, or you can also use the tutorial projects. If you'd like to go a little bit more in depth, you can request a demo if you don't want to just have a trial by yourself, via our website or email, and we can reach out to give you some support. Okay, thanks for the time. Youssef, do you want to give us a hand and we'll start answering some of the questions that have come in?
Sure, let me just activate my camera. And now we'll take questions. First of all, thank you, John, for this great presentation. Really appreciate it. I mean, you covered one of the questions already, which asked basically if we can simulate airflow through HEPA filters. So airflow, yes, for sure. Filters as well, like we have the capability to simulate porous media. So if you go to the SimScale documentation, you can basically check out all the porous media approaches we have. So I bet this is definitely something that's possible inside of SimScale. Another user is asking, is there any minimum hardware requirement for running SimScale? I think that's an interesting one, which we kind of covered during the presentation, right?
Mm-hmm. Yeah, I think we did. It's an interesting question, actually. So far, we haven't seen any minimum, haven't seen any problems with very, very limited hardware. We have lots of different users from all over the planet running SimScale on very, very old machines. So no, I would say not really. There's nothing really done locally. So you just need an internet connection. That's the important thing, to have a strong internet connection. Everything else is really done remotely. So everything that you see is held on the cloud and run on the cloud. It's also all encrypted, just to be clear. So we can't see anything, no one else can see anything, unless you choose to share it with us.
Excellent, I think that covers it. The next question is also a very interesting one. What's the difference between the free and the paid version of SimScale?
Yeah, I think that is an interesting question. Let me share a couple of examples. I think you can still see my screen, right? So
yeah.
There are a couple of fundamental differences. One is access to specific analysis types. So the free trial does have access to nearly everything here, apart from a few things. So we have a couple of specific solvers here, a subsonic and an LBM solver that our community or free trial customers don't have access to. But pretty much everything else is available. The other main thing is that all of your projects would be public. And that's normally what our paying customers move away from, because they want access to privacy and they want access to the other types of solvers. The other main limitation is that you don't access the very large cloud machines. So some of the machines that you have are something like 16 cores in the background maximum. But once you move to being a full customer, then you have access to the much, much larger machines.
Great.
Cool.
Another question we have is, what is the main benefit advantage of using SimScale over other CFD softwares such as ANSYS or even SolidWorks?
Yeah, good question. I think a couple of things for us. One is accessibility. So you have access from anywhere. You really don't have any local hardware requirements. So really the kind of startup, I guess, wall that you have to jump over is pretty low, right? There's essentially low cost and low hardware requirements. And the other fact that we're essentially multiphysics, so we have everything in one place. So you can run every different type of analysis through very, very similar types of workflows. And being cloud-based, you can collaborate globally. So it's very easy for me to share a URL, the deep URLs too. So from wherever I am in the software, I could send you my URL and then you would get to exactly where I was, and we can start to collaborate and communicate.
Great.
I think maybe I'll add to that. I mean, the kind of main fundamentals are very similar. I mean, we're all solving the same kind of physics problems. We all have, well, nearly all have pretty good accuracy. We definitely do. So like physics aside, I think we add all of these different types of things on top.
Great. I think a very interesting question is also, can you do moving geometry like gas flow in a piston going up and down?
Yeah, good question. At the moment, no, we can't. We don't have moving parts. We have some very interesting things going on different to this, but no, we don't have moving parts. We are working with a lot of people to do geometric optimization and like really cool stuff. but they're not actually moving anything right now. The only exception would be rotating machinery. So we have a specific solver tailored for rotating machinery, where of course those parts move, but they rotate and they're not linear motion.
Mm-hmm. Next question would be, can you design a CAD module inside of SimScale?
No, I would say no. You can optimize it and improve it and understand what's happening inside it and get some really useful insights, but we're not a design tool. So the CAD part of SimScale that we have is really there to help you simplify your CAD, make it ready for simulation, or once you've run an analysis, modify it and then run a comparative type study. But we're not really here to reinvent the CAD world, to be honest.
Mm-hmm. We have two questions regarding pricing, so I'm trying to pack them into one. Basically, is it pay as you go, or is it like a subscription model, which we are basically giving our customers, and what are typically costs involved?
Yeah, I'd say both. So we have customers ranging from customers who want to pay monthly to those who pay annually. Of course, it's cheaper overall if you're a heavy user. I mean, some of our customers have 50 or 100 users easily in their companies. And for them, it's much, much more sensible to pay annually. We have small customers who are just paying monthly, for sure. I would suggest if we get into really wanting to understand, or I wouldn't answer the money question. So I think what makes sense is to talk to us directly. And we would figure out if we can first add value and make sure that we can solve your problems and then have that conversation.
Mm-hmm. Another question we have, will SimScale simulate an airflow from a room through a grill and along a duct and show the airflow inside of the room as well as the grill and duct? I think that's straightforward.
Yeah, sure. So we have customers looking at, I guess, kind of micro and macro. So you could go from things like we looked at today, like the valve, which is quite small, up to building size. So you could have a whole duct system with all the rooms interconnected, up to city scale. Leveraging the cloud, obviously, there's not really a kind of limit. So most things are pretty possible. So yes, to answer your question, we can.
Mm-hmm. Great. Very general question. If the free trial enables us to simulate a real ocean water flow.
Yeah, you can. The free trial actually doesn't. We do have a multi-phase capability, which means you can run water and air, but it is not available through the free trial, no. But we do have that possibility.
Okay. Then, if you have any more questions, please put them in the chat. Otherwise,
yeah, maybe I'd answer. I mean, we have a couple here too, and I'd answer the first one in the chat as well. I think it's quite interesting. So is it for like initial estimation, I guess, is the question, or can we have like detailed analyses? I would say both. The way that SimScale is set up and all of the default settings are going to give you something that should be very accurate, like within 1% or 2% as a general rule. So we are kind of equally positioned, I guess, with the leading tools in that way. But if you want to, sure, you can reduce the mesh down, kind of lower the settings, run it much quicker and get some initial estimations too. I think we have users doing that. So the estimations are good if you want to get some quick comparisons between one design and another one to see which one is best. When you've identified, hey, this one I think is best, like use the default settings and get a really accurate answer.
That covers this. A very interesting one is, can we use parallel processing?
Yep, that's exactly what we do. So we do exactly this in the cloud. Everything is parallelized and we're running on many, many cores at the same time. The other thing we can do as well is run multiple analyses on many machines at once. So everything is parallelized anyway, but you could run 100 simulations at the same time. Yeah, again, without your local hardware having to do anything. So everything is taken care of remotely. Yeah, hopefully that answers the question.
I think that's a big benefit. Gives me like university flashbacks where you had like a software on your machine and you couldn't do anything while it was simulating.
Yeah, I remember. I think we had to design a very simple valve that went around a U-bend or like a 90-degree bend at university, and it took overnight to run or something. It was just crazy. But that was I'm a bit older, maybe 20 years ago, if I'm honest.
What are the data export options for simulation results?
Yeah, good question. I'm not sure if I can answer it in enough detail. Everything is transparent and you can download all of the results that you have. What I know at least is that some users are using that to do local post-processing. Yeah, but I would suggest reaching out to us if you have specific needs, and then we can figure out if we can meet them or not.
I mean, for a general export, I think you can demonstrate everything or post-process everything in ParaView as well as in TechPlot. But if you're a fan of open source, use ParaView.
Mm-hmm.
I think that covers it. Does SimScale offer a pre-dawn CAD of turbines such as Kaplan turbines?
Yeah, good question. It depends, I guess, what you wanted to use it for. So we have a massive community with something like 1 million simulations now. So there's loads and loads of data there that you could use to leverage. As to whether I'd recommend using that, I'm not sure. So I think it depends. It really depends at the end what your end goal to be. So yes, you could use our community to do some experimentation with a Kaplan turbine. But if you wanted to make sure, hey, it's a really good design, then I would make sure that you pull from a good design in the first place.
Also, the person asking the question, I just shared a project with you. So if you go to our public project library, just type in any turbine you would like to have, and then you get plenty of options. Just copy it into your dashboard and play around with it. That covers this. Can you run hydrodynamic analysis on SimScale?
Yeah, I think we kind of answered that before with the multi-phase question. Very similar, yeah. I think. Yes. Yeah, but again, it's not available for free trial users.
That covers every question so far. We'll give it a couple more seconds, and then you can post additional questions in the chat. And in the meantime, if you are looking forward to learn more about simulation, go to simscale.com/webinars-workshops, and you can find more webinars from SimScale. One which we are really excited about is the Rimac Automobili webinar. So they're developing a hypercar, or actually produce hypercars from Croatia. Very excited, and they did battery simulation with SimScale. If you're interested in that and hypercars, make sure to join us. simscale.com/webinars-workshops. There you can find more information. Thank you for the feedback. One question that's coming in is, do you have to detail all the result outputs you're looking for, e.g. displacement, stress, acceleration, before submitting for analysis? Can these be accessed post-analysis? Very good question.
Yeah, good question. Yeah, everything, you can do both. So pretty much everything is available afterwards. So everything that you've written there, you would get access to afterwards, but you can set up specific result controls before you want to run. So you could say, hey, look, this part I'm really interested in, or this point I'm really interested in. Please tell me what happens to this over time, for example. So you can be very specific if you want it to be, but everything you've written there, you would just simply have access to all of it by the end of your simulation.
I think a misconception is also then run a simulation and then trying to access something, but you have to predefine it like as a result control item and then run it, and then you could access it. This has been asked in the forum quite a lot, but I think John, you answered it quite well. That's it so far. Yeah, if there are no more questions, I think we can leave it at that. As I mentioned, more webinars can be found on our website. Thank you very much for attending. Very nice questions, very nice demo from you, John. Thank you so much for joining us today. And thanks for IMechE to allowing us to present today on this webinar on multiphysics simulation with SimScale. Thank you so much. Enjoy the rest of your week, and goodbye.
Thank you. Bye.